Hey guys, hello and welcome to a new video. And this time a free case by MEWC DACH written by myself. And it's a case about a game that is quite famous in the actual esports community called MEWC DACH. And yeah, basically you get like a city and a country, or in this case it's a US state, and you have to find it. So in this case, I know where Maryland is, so here DC, Baltimore, I don't know. Was close. Yeah, you tap somewhere and get scores. Let's do something far away. So in this case, it was super far away, and I only got a score of 8 because it was 12,000 kilometers away. And yeah, basically, we are working with on this game in this case. Level 1, country of the listed city, basic XLOOKUP for the city name, returning the country. Then, how many cities of the specified country are on the list? This is basically in count if s. Yes. Then this is a little bit different. This is a form of lookup stuff. So we're searching for an item in all columns here, and then want to return one of those columns where we have a match. And if there are multiple options, then we want to have the first in alphabetical or numerical order. So how did I do this? I compared the item to the whole table. And then you get a split array out of, in this case, zeros and ones. And then I made a sum by row. And then we filter by this. And what do we filter? In this case, we do an XLOOKUP for the data point. In the first column, returning all columns below. And we then get a list, in this case, all German cities. We sort this, and sorting is working for both numerical values and text values. And then with the intersectional operator, I get the first value of the array. And we are done. Now, level 4. In level 4, we're using the reverse engineered, because it's not an official formula from MEWC DACH, we're using the reverse engineered scoring formula. In this case, the formula is 100 times exp function minus 0.00022 times the distance, and this then rounded up, round up to the next number, and we're good to go. Then, now, sorry for this level, but to calculate the distance based on coordinates, you have multiple formula options. And one formula option is the so-called Haversine formula. And yeah, we're using it here. And for the Haversine, we need 2 latitudes and 2 longitudes. So, the first latitude we get from our city, and here's a small trap, because those cities appear there multiple times, and you should therefore work with this code, also including the country. So, let's return the latitude. For the longitude, we're doing the same, and simply adjust the column. And here for this, it's always written in that long form here, text before. And then minus minus substitute, in this case, substitute out the degree sign and substitute. I have to substitute out the point against the comma because I'm on European number settings. Small advantage for US number settings people, user. Now we have all latitude and longitudes, and let's do the Haversine formula. And I'm starting this Haversine formula as a lambda because we might need it later. So originally start as a lambda, lat 1, lat 2, longitude 1, longitude 2. In this case, 2 times 6371 times arccosinus asine of the square root of the sine of radians of latitude 2 minus latitude 1. Lat 2 minus lat 1 divided by 2, close bracket, close bracket, close bracket, to the power of 2, not close bracket, plus cosine of latitude 1, radians, of latitude 1, multiplied with cosine of radians of latitude 2, we could still in our square root, which is correct, multiplied with sine of radians of longitude 2 minus longitude 1 divided by 2, close bracket, close bracket, close bracket, to the power of 2, close bracket, calc error. Yes, because we are missing here out our argument. And then we have to round. Let's do this directly here in the lambda. And we have to round to the full kilometers, so the nearest number. And then we can simply, we cannot simply copy this down. What is wrong? Here's also something wrong. First fix this. So 6371. Let's use a robot to format this formula. 6371 asine square root sine radians divided by 2 to the power of 2 plus cosine radians multiplied with cosine radians multiplied with now what the issue is. So it was here or is here missing bracket. The question is where? Here. No, still not. 6371 asine square root sine radians latitude longitude divided by 2, 3 brackets, so we close this here, to the power of 2 plus cosine multiplied with cosine multiplied with sine meridians divided by 2 close 3 brackets There's something odd here. Something odd. Text after. Still wrong, but wrong differently. So a sine square root sine radians 2 1 divided by 2 power of 2 cosine sine here we go. Now we're talking. Sorry guys. Yes, I of course then also have to copy it down here, and everything is fine. And I then save lambda s, so I can then reuse it on the later levels. Half sine okay, let's do the next level in the data table format. So here we are playing a full round. So XLOOKUP for city in here. Returning latitude and longitude. And then text before minus substitute out the degree sign against nothing and the point against a comma, and then text after. Now I know. And copy this here, and here. Hover sign, latitude. Yes. Latitude, longitude, distance, rounded, and then the point formula or the score formula. Four, yes, that's right. 4, 3. And then, because here are then some multipliers, first round, second round, no multiplier, third round doubled, fourth round tripled, and fifth round tripled too, and then sum is 251, which is right. And we have calculated everything, and it's right. And we can go to level 7, and we will build level 7 out of level 6. So adjust here. Yeah, I know some stuff has to be reversed. So what is done differently in level 7? In level 7, go back. In level 7, we have given because you normally don't tap on coordinates directly, you tap on something a little bit more less granular. We're using this map here, and you're tipping in cells, and the cells you're tipping in or tapping in are given. And based on those cells, you can calculate, or based on the cell address, you can calculate the latitude and longitude, and we're using all 4 corners of a cell, so this corner, this corner, this corner, this corner, converting it to latitude and longitude, and then doing the same as before. Yes. So I think I want to have this down a bit. Row number from cell reference, standard lambda, and column number from cell reference. You can also use row and indirect, but they are volatile. So, and then I have to convert this into latitude and longitude, and simply have to adjust them. So we're starting with overriding this a bit. We're starting with 1, 1. And cell A1 is starting at latitude 90, and the latitudes are going from 90 to minus 90. So with an increasing row number, you're going actually down in the latitude number. And therefore, it's 90 minus row number plus 1. And we're doing this multiple times because we want to build the combinations. And it's also 90 minus 1 without plus 1, because you either tip at the top of the cell or the bottom of the cell. So here we have then our latitudes. Now let's do our longitudes. And our longitudes are starting from minus 180, and for every column we are going plus 1. We're adding 1. So that's a bit simpler. So equals minus 180 plus column. In this case, we would start at minus 179, and therefore we're subtracting 1. Or we're doing this without subtracting an additional longitude. And now we have all combinations, and we can simply use the Haversine formula on this. Yes, and this, and this. Yes. And I can then track this down. Now let's revert to this here, and we can then copy it in here simply, and you see it has adjusted to everything, and we can then simply use the minimum kilometer distance. It's already it's not rounded, or it is rounded because my Haversine is rounded. Okay, fine. And then the score formula based on the minimum. And now we have to consider something else, because if we are tapping in the same, so let's say we are in Montreal is Canada, DE 34, and we actually have tapped into Canada, then we get 3 bonus points. So indirect map and our coordinates here is indicating where we're tapping in, and then text after. And here if this equals this, then 3 plus our points, otherwise our points. And we're matching now before the multiplier, and then multiplier 1, 1, 2, 3, 3. $81, 8, 12, 30, 35, 57, and summing all of this up, calculating everything, and we are good to go. Now, let's do the bonus questions. How many city names appear multiple times in the list? I think I do this directly here. Count if s. Filter. In this case, it's 18 times, but since every times is I formulate this differently. There are only 9 unique cities, and that's the point. So our answer is 9. Which country has the most cities listed in the list? Listed in the list. And I do this by group by. I could use also most of, but yeah, group by is also fine. Count A, -2, and it's United States. What actual country is the largest based on the number of cells on the map? So we have to let's do it that way. Count if s. Our criteria range is the map, and our criteria are given here by all existing countries there. No, that's not good, because we have maybe different writing. Okay, then flatten map. Or most of, yeah. Now, either flatten map or using my most of lambda. Oh boy. This took too long. Unique to call. It's not that large of a map. Okay, and then count if s. Is my most of lambdas that slow? I had no idea. And then equals sort. So Ocean and Antarctica are no real countries, but Russia is, and is therefore the right answer. What distance given in full kilometers would still yield a score of 100? Yes, I know this will be an issue. Let's do it at the side. And then sequence 100. And then X match 100 from last to first. 45. Here we go. What is the distance between the two cities in the same country that are the farthest apart? Round to full kilometers. I brute force this. Permutations array. Up to 1000, only 2 numbers, order of numbers matters, don't allow same number combination. Why is it so slow? It is 499,000 combinations. Oh, maybe it's on. I think I should deactivate the indirect stuff. That may be the issue. So here I'm using indirect. So formulas, no, it was developer properties. False. Okay. Hopefully this will help. And then equals index of the country. This equals this, and then we filter the numbers where we have a combination of the same country or between the same countries, and we're now down to 7,209 combinations, and that's way easier to brute force. Still not great, but easier. Hover sign, distance. Is this right? Hover. Latitude, latitude, longitude, longitude. Here it is. And the maximum is 8178. And that's right. 12,050 points. In 27 minutes 30, which is good. Yeah, still a lot to do. I haven't thought it would take me that long, but anyways, I hope you enjoyed it, and yeah, see you in the next one. Bye.